Okay, guys. So I just people have been telling me I didn't do anything for chapter 9, and I'm now realizing that I hadn't. I thought I had because I nobody ever emailed me last semester saying, "Oh, where's chapter 9? Like you didn't cover it." So I never even considered the possibility that I didn't do it. But I couldn't find this in the videos anywhere, so I'm going to do a couple of examples through this right now to help you. So to do this one, it says determine the best the point estimate of the population proportion, the margin of error, and the confidence level, or for the following confidence level and the number of individuals with a specific characteristic. To do this, it's pretty straightforward when you have been given the lower and upper bounds. The lower and upper bounds are calculated. So what happens is they find the average number of people who have something in a test, and then they give a margin of error. And you've probably seen this with the election because they say, oh, this right now, I think I heard him say just a minute ago, Trump is within the margin of error of victory in that state, which means that they're predicting Biden will win, but within the margin of error means there's a 4% chance he will perform better than they think, or a 4% chance that they think that he will perform worse than they think. So they're not really sure, or something like that. It doesn't have to be 4% though; it can be any percent. So what happens in this case is you're going to take the values they've given you, 0.101. So we're going to take 0.101, add that to 0.699, and then divide that by 2. And we get 0.4. So our answer here should be 0.4. So I'm going to go ahead and hook my laptop back, or hook my keyboard up. And we're going to put 0.4 here, and we're going to check it, and it's going to be good. Okay, so that's taken care of. And then margin of error, to find that, just do 0.4 minus the lower boundary. The margin of error, so okay, this is the best point estimate, which means it's halfway between the lower and upper bounds. That's what I did. I took the average of them. And so if you take this number and subtract this number, that will give you the margin of error that they're using for this. So if we do that, 0.4 minus 0.101, 0.299 is our margin of error. Okay, and then finally it says the number of individuals in the sample with this specific characteristic is, well, n is 1,000. The average here is 0.4, so we just multiply those and we get 400. Okay, so that's that. Now to do this, you can do this very simply with a calculator. I know if you use question help, it's going to give you some crazy thing. I'll show you how to do it. You're just going to go second, stat, not second, just push stat. Sorry, you don't need second. So push stat, go to tests. You're going to look for the one that says one prop z int. Hi Deshaun, give me 1 second. I'm just making a quick video. So we go to one prop z int, and then you're going to put x is 120. You're going to put n is 200, and the confidence level is 90% from the problem. Oops. And this is your interval, so this is lower, this is upper. So 3 decimal places, 0.50. Sorry, 543 and 0.657. Check it and it's good. And that's that. So to do the next one, I mean, you're probably going to do the same thing. It gives you a confidence level, interval, and things like that. Just use the same calculator stuff, and I will create more content as we need it. Thank you, guys.